Hi everyone, and welcome to this video. So today we're going to be looking at the set data structure that Redis provides. I say it provides for us a way in which you can be able to store unique items, and the order does not actually matter. So let us begin by creating a simple list to demonstrate what we are actually talking about. Right here in my Redis CLI, I'm going to begin by creating a simple set, and I'll use the set add command. So I'm just going to say s add. So this takes in the set key. Now I'm going to create a simple list of programming languages, and it's going to be Langs. So let me create it and call it actually Langs1. So this will take in our member. So let our first member be a programming language such as Python, and let's say we are also going to add Java. We can add PHP, we can add C#, we can add maybe Go, and let's say that. So once we do this, I'll go ahead and add our items. So this has gone ahead and created our simple set. Now one of the things that we can try to do is to add one of the items that are existing to prove that this actually stores unique items. So I'm going to go ahead and use the sadd command, then specify the same set, and I'll say Langs1. So let's say we try to add Python. Now this is going to fail because it's going to return an integer value of 0, and it's going to fail because in a set you can't have two items that are having the same string value. So let us go ahead and try to retrieve all the members present in this set. The way we do that is by saying s members and then provide the set key. So in this case we shall have Langs1, and this will go ahead and return all the items within our set. Now in case we want to verify if a certain item or a certain member exists within our set, we can use the s is member command, and what this does is to basically take in the key. So we can say Langs1. Now we can check if Rust exists within our list of programming languages, and now it doesn't exist because we are returning 0. So let's say if we check for something that exists, so let's say we're going to check for our Python. In this case, it's going to return 1, meaning that Python exists within this set. Now, apart from just adding, we can be able to also remove an item in case we want to get rid of it. So I'm going to do that by using the srem command, and by specifying, we have to specify the name or the key of the set, and in this case it's Langs1. Then specify the member, and in this case our member is going to be maybe C#. So I'm going to remove C#, and this will return 1, meaning that our C# has been removed. So when you try to access all the members, we're going to see that C# is no longer part of our set as it was at the beginning. So apart from just adding and removing items from our list, we can be able to carry out things such as set operations. Now if you're familiar with sets from programming languages and maybe set theory in general, we have some set operators such as union, intersection, and differences that we may operate on sets. So we're going to be able to explore some of these in detail. So to begin, I'm going to begin by creating a simple second set. Now I'm going to first clear our terminal right here, and then I'll go ahead and use sadd to create this set. So I'll call this Langs and then 2, and then I'll specify the members. So let's say we're going to have Java, we shall have PHP, actually called it HPHP. So this is going to be PHP, and we shall have, let's say, Ruby, and then let's say we shall have Kotlin. So let's also add another programming language here. So let's say we're going to have JavaScript, and let's say we shall also have C++. So I've added 1, 2, 3, 4, 5, 6, and let's also add one common one that is going to be common to all, so which is going to be Python. And once we have this, I'll go ahead and press enter. So this list has 7 items. Now in case we want to carry out these operations, we shall begin with our SUnion. So I'm going to begin by demonstrating by using the SUnion command. So when you use the SUnion, we shall provide the keys, and these are just the set keys. So in this case, let's say we want to find out items that are in all of the sets combined. Now we shall have LANGS1 and then have LANGS2, and this will return all the items that are going to be within the lists. Now if we are observant, we shall realize that all of the items that exist in both sets are actually referred to as one unique item, just like we see here. So we have items that are common to both lists, such as Java and Python, and those are all one. So let us go ahead and try to find out items that exist between the two sets. So the way we're going to do that is by using the sinter command, and this takes in the list keys, actually the set keys for the specific items that you want to check. So in this case, I'll go ahead and provide langs, and in this case it will be langs2 as well as langs1. So when you go ahead and enter, we're going to find out that the items that exist in between these two sets are Python, Java, and PHP. Now in case we wanted to store this maybe in another set, we can use the sinter store command, and this takes in a destination set. In case it will go ahead and actually create a destination set where it shall keep the result of this command. So let us go ahead and create that. So I'll just call it langs3, and this will take in the langs, the sets, and these are the sets that we actually created. So we shall have langs1 as well as langs2. So when I press enter, in this case we shall have the 3 items taken to langs3. So if I find out the members in langs3, this shall have Java, Python, and PHP, meaning that we have all of them stored just there. So let us try out some set differences. So I'm going to begin by basically find out the items that exist in set 1 but do not exist in set 2. So I'm going to begin by doing that. So we do that using by set diff, and in this case we shall provide keys. So in this case we shall have langs1 and then langs2. So this is very similar to saying something like langs1 minus langs2, which will return only the items in langs1. So when I press enter, we shall find out that Go and Dart are the only programming languages that exist between langs1, but they don't exist in langs2. And in case we wanted to store it, we may also do something like sdiff store, and then you provide the destination array. Now I'll call this a destination set, which I'll call langs4, and in this case we shall go ahead and provide the results. So let's say langs1 and langs2. Now this will go ahead and provide this. Now in case we wanted to find out langs4, so in this case I'll say langs4, that will go ahead and return Go and Dart as the only items in langs4. Now I hope you've got to understand some of the commands that we have in our sets, and in case we wanted to remove items, we may do sremove. So let's try that. So I'll just come and say srem and then provide a key. So let's say I wanted to get rid of Java in our first set. We are just going to do it like this, and this will go ahead and remove Java from our first set. So if in case we wanted to say members and then let's say langs1, our list will be returned, but it will not be having Java. I hope you've enjoyed and learned from this video, and if you've done so, please leave a like. Don't forget to subscribe if you're new. Thank you for watching, guys, and I'll see you in the next Redis video. Bye.